project is a very steep learning curve, but we expected that. The only way to gain experience is to do things. And we're fortunate that the government has allowed us this opportunity. We believe that we can go on from this and sell these things.
As the months passed, management and crews moved over the hump of the learning curve.
Like any multiple ship project, that once you get the first ship under your belt, once you've banged your head, once you've tripped over a few times, then the whole thing starts to run efficiently, and that's what we're seeing.
Everyone involved began to get a sense of the potential this project could herald. At Point Hope Shipyard, the long term was starting to come into view.
The learning curve has been better than we ever thought. The guys picked it up, I guess partly because they're seeing a future in shipbuilding now, which I don't think a lot of our workforce here has seen for some time. So I think with the great interest in it and seeing a future, they picked it up. The workforce seems to be genuinely interested, genuinely happy to come to work in the morning. Therefore, almost daily, the productivity is increasing. I see it as Point Hope's future.
Without this project, this company would not be here today. Fishermen are not getting their boats fixed, so there's been a slowdown. I mean, even the Department of National Defence has had cutbacks, and they're not refitting their ships as often as they used to. And at the moment, we're about 130, and 130 all-year jobs. So the impact would be quite significant to the working base of Victoria.
At CFI, there is sober optimism, tempered by an acknowledgement that the project has had its detractors.
It doesn't matter where you are in the world today, there's always someone telling you why you can't do it, and your ship will sink and you've made it out of the wrong material. But we all get past that.
For every phase of the PacifiCat's construction, a massive amount of design data had to be generated, coordinated, and effectively communicated.
The job we do here is convert the structural drawings into drawings that are buildable. So we take the information that come from NCAD and convert that into geometry, which is cut down on the burning table, parts lists, data lists, which also use for production, and to a certain amount make sure that the hull is buildable. It's similar to when you do sewing and you have a whole bunch of patterns and you try to get the most out of the material. Well, we do the same thing, except it's in aluminum. We know what our material size is, and we know what the geometry or the shape is, and then we try to nest that stuff in the plate to get the most utilization of it. And that's all done in AutoCAD, which is a computer-aided drafting program.
Training programs were essential to equip workers with the unique skills the project would require.
Each welder went through a 7-week training program, and at the end of the day tested to the ISO welding code and also the CWB welding code. That, to me, has been a great part of why our quality level is where it is today.
CFI worked with the British Columbia Council of Marine Industries to develop a comprehensive aluminum welders training program, with courses offered at BCIT in Burnaby, Victoria's Camosun College, and North Island College in Port Alberni. With Australian and Finnish sources sharing information and experience in the building of the high-speed aluminum vessels, the program has trained hundreds of welders to date.
Most of the students came out of the shipyard originally. They came through the union. More recently, we're starting to look for people out of the local colleges. It's meant a great deal of employment, new employment. We've run over 300 people through this facility, probably another 150 to 200 on the island.
When we were undertaking the training, we were closely involved with BCIT, and we were approached by their Department for Women and Trades. They came to us with a very good proposal for some funding for the women to be trained, and we took the opportunity, and it's worked out very well for us.
In the trades, there's definitely a lot of opportunity to make some money. And I needed to do what I felt was the right thing by my child. I needed to provide a means of supporting her. And so I think, honestly, that was where it started.
I wanted something more physical. I didn't want to be in an office anymore. Just a lot of things I looked at, things that I had done, things that I didn't want to do anymore, and things I wanted to try.
Oh, it's hugely rewarding for me. When we went on a tour on last week of the ship, I was just thrilled to see it all coming together and being so large and overwhelming, really, and being able to point out the little bits that I had done. It was quite exciting.
At Alberni shipyards, the intensive training programs are paying off, equipping the company with the skills they will need to stay competitive.
Each of the welders had to pass rigorous testing, not only practical but in written, the theory of welding aluminum. We have 30 men here that have gone through a very rigorous course, and they're gainfully employed over the last year having done that. We've had the benefit of doubling our manning. We have historically been a steel yard in construction and repair. We have had experience in aluminum, but obviously not to this scale before. The springboard opportunity with the benefit of acquiring or strengthening our aluminum skills is obvious and something that we will take advantage of in the future.
In the end, every weld, every facet of construction must meet the code and quality standards of DNV, or Det Norske Veritas, the Scandinavian-based classification society that sets the premier building and safety standards for high-speed vessels.
The classification society is akin to your city planning department. So it's a set of guidelines which the designer and the builder has to follow. It also gives you a huge degree of comfort knowing that these are the rules which are applicable, and if you build to these rules, then you're not going to have any problems with the design of the vessel.
PacifiCat's massive components pose unique challenges to engineers and builders intent on meeting DNV standards. The Leica alignment device works as a kind of high-tech surveyor's tool, generating a perfect 3D virtual grid inside the shed, along which the actual vessel is aligned. In some ways, the project is more akin to the aerospace industry than to traditional shipbuilding in terms of the precision required and the technologies employed.
The big difference, I would say, with the aluminum is the requirement for the weight to be controlled so precisely that components are lighter. It's more like a wristwatch compared to a grandfather clock. The precision has to be there, but the parts are smaller and just more difficult to work with. Our techniques for alignment of various structural members have improved tremendously. The actual knowledge and competence of our welders is increasing steadily and constantly. We anticipate seeing improvement all the way through the third ship, let alone the first and second.
CFI's marketing